All right, so I've wanted to do a video on translating C++ classes for some time. And I thought I would do like a kind of an intro thing here. We're not going to go over everything that you might think about when you're doing this. Because, I mean, the truth is there's a lot that, C++ is quite a wide language. There's a lot going on in a lot of different contexts and so on. And on top of that, basically, there's a lot of depth as well, right? Each feature itself can have a lot of depth. Also, when you consider the interplay between different features and so on. So, with that in mind, we're gonna take a look at sort of, hey, I have some C++ classes. How do I translate parts of those? Which parts do I not translate because they don't actually even make any sense, and so on, right? So let's take a look at a very basic example here. I'm going to try to kind of explain this so that even if maybe you're not necessarily, you haven't done C++ before and so on, you should be able to follow what's going on and so on. So we have this element class here. By the way, I should note that when you see class and struct, right, these are the same thing. They're just the same. The only difference is the default visibility, right? So this class here, you can see it only has public things. Public and private are basically visibility modifiers and so on. So public is, we can access this when we have an element. We can do element dot something. That is what public basically means. When you have struct, things in that thing are public by default, right? But you can at the same time just say private, and then you can have int c here, right? If you want to. So that's the only difference. We're doing class here. No real reason for it, to be honest, right? To be honest, I think you should probably just, when you have structs, I think it's fair enough to just say, I don't have a visibility modifier. When you have classes, I feel like you kind of have to have them. Don't ask me why I think this, because it's like, I just think it should be more obvious. I think you should have public and private. If you do have anything in them, you need to have very clearly specified what is what and so on. I think you should mention them specifically. Anyway, so we have this element here. It only has public things. It has a value here. It has a constructor. So when you see a function that is basically a function definition or method definition, sorta, that is the same name as the actual class that we're looking at. That's a constructor. And the colon syntax here, colon value 0 here, says value, the member, should have the value 0, right? And then we print that we're running the constructor. This is just for visibility in the example. We also have another constructor here that takes an int value and sets the value inside to that value, right? And here you might actually see in some cases param value, for example, right? So that's how this interplay works here. And then we have this thing with the tilde here, right? The squiggly thing. This is a destructor. So when you see the same name as the class itself, after a tilde, that's a destructor. This is basically supposed to free up any possible memory that the class has and so on and so forth, right? Sometimes you do not have to write these. They will exist regardless, to be clear. C++ doesn't generally do like this doesn't exist, so nothing will happen. It will basically code generate a lot of these things for you, and so on. So this is a very simple thing here. Let's take a look at sort of just what that means in Odin just real quick before we move on to the slightly more complicated thing. We have an element here. It has a value inside. We don't have constructors. If we did, there would just be procedures that return that thing or whatever. They might initialize that thing if it's, that's more of the ordinary way, so to speak. Destructors, on the other hand, if we do want them, in this particular case, of course, we do not need a destructor, right? Because this just has an int, but we didn't need that in the C++ case as well. We would create a procedure, right? That says here, well, in this case, we're just printing that we're running this. It takes the element, it does something with it, and so on and so forth, right? That's basically it. So it's just a procedure, right? So let's take a look at our container, and I'm gonna actually going to rename this. Sorry about that. There you go. Sorry, and let's see here. We are going to have, we're going to look at this slightly more complicated example, which is using public and private and so on here. So in the private section, we actually have two things here. We have a vector and the value here. This vector stores elements, by the way, I should say, here. And then we have different constructors. And this can get exceedingly complex. We have the straightforward thing here. We have a constructor that takes no arguments. What it will do basically here is set the value here to 0, and then it will actually construct a vector and push back 2 values. That's adding 2 values to that vector, right? We have a destructor here. That does stuff. Yeah. And then we have here a constructor that takes a value, sets that value, creates a vector, pushes back to that vector, etc., etc. So there are different ways of constructing these things, and there's an important note about that. So let's run this program and see sort of what happens. I'm going to comment some stuff out just so we don't get spammed too much here. Sorry about that. So here we can see that we have a program, very simple, straightforward. There's one construction here of a container. Here we create a new scope and create a container. Here we create a new scope and do more things. We create one container, and then we create a container that takes another container, right? We're going to see what that means. And then we print some values from these containers and so on. So first we can see we construct a value here. That's this value here, right? Here we can see that we have this one, and that's this construction. Then we can see that we run a destructor, right? This happens because this value falls out of scope. When this scope ends, this value will no longer exist, and it will run its destructor automatically. This is known as RAII. Resource acquisition is initialization. That of course only talks about the initialization bit, but the destructors here are very important. They are central to the whole thing. Construction and destruction are connected. They are equally important in C++. They are core to C++, how it behaves and everything, right? That is why you find often that people who are sort of into C++ will desperately need these in order to do things, right? It's a common criticism of, for example, Zig, or I guess Odin as well. Why don't you have RAII? I cannot work without this, right? And that's, you know, because these are core to C++. If you have internalized C++ and you're fine with it, there's a good chance that RAII is just how you think, right? You just can't imagine a world without this, right? And that is the concept of when we create these values here. You can see here, we are running a constructor. In fact, we're running a constructor without any arguments. Same with this one here, right? Here, we're running a constructor with an argument. So we can see here that this is container constructor with value, right? And then there's an interesting thing here. We pass E2 when we construct E3. And that one is interesting, right? Because actually means that is this copy constructor here that we're running. And a copy constructor is basically taking another value and copying the values from it, right? So just with very small, minute differences in how we call this code, we have gotten different value, different behavior, right? So that copy constructor is running here. And here we can see that the values have indeed been copied, right? So E2, if we go to E2 here, right? We print E2's M value and we print E3's M value. They are the same. Then we print their vectors and we can see these are not the same because they are residing in different parts in memory, right? And they have different values. That's because the copy constructor, in fact, this copy constructor here actually adds a fourth element just to make it kind of obvious that, hey, this has been copy constructed, right? So there's a slight difference here. And we can customize this behavior by doing all of these things, right? There's also this interesting thing here, move, right? Move constructors are not a thing in Odin at all, right? Odin never moves memory for you. You can move memory if you want. Just for those who might not know what that means, it is effectively a one thing taking over the memory of another, right? The other memory is going to be zeroed out. It's not going to have any values at all. Basically, taking that and moving it to another thing, another container in this case, right? That is a move constructor. So, and then this is basically the C++ program. This is of course completely made up just for this example. And I want to kind of show how do we do these things in Odin, right? Just a brief kind of overview, right? We have our container, we have our value inside, which is an int. We have a dynamic array of elements, right? Dynamic array is basically the equivalent of this vector in C++. We're gonna look a little bit at the differences between these, right? The differences in what we are expected to do and say in Odin, and so on. So when we make one of these containers, we create a procedure here that takes a value, takes an allocator, and produces a container, right? Here we allocate some space for these initial values that we have, 1, 2, and 3, like in our other case, and then we return the container, right? So that's our kind of normal constructor with a value. Here we also have this delete. You'll note here that I'm namespacing this, right? So example underscore make, example underscore delete, and so on. This is really just a convention. Feel free to do whatever you want, right? And this takes, of course, the container in question here. And of course, these functions should be called container. Yeah, let's actually do... let's do this. There you go. Now it's container make, container delete, and so on. So when we have this function here, this is a destructor. We have container delete. It's a procedure, takes a container and just deletes the container, right? And here we can notice kind of an interesting thing here that we never talked about in C++, right? I'm going through each element here and deleting it. And then I'm deleting the actual dynamic array, right? And that's interesting, right? Because now you would think, oh, well, hang on, why do I have to do that in Odin? Well, this is something that C++ does for you automatically. This, in fact, is why we were spammed so much in the beginning. So notice we have this output now, right? Notice now how much output we have. We have a lot, right? We have constructors and destructors for these. And just to be completely fair here in terms of output, I'm gonna comment out the constructor output for our element type. You can still see that we have a lot. And so something should stand out to you here, right? I will compare this to the Odin code here. The Odin code here is, there's more, right? There's just more. However, we are asking to delete this container. all over the place, right? And if I go to that function, we can see exactly what's going to happen. We can see that element delete is going to be called and so on, right? So that's a difference. I'm not asking for any of those things here, right? So the emergent behavior of basically having RAI be a thing in C++ has basically, it's doing a lot. And I think that there's an aspect to this that I think is important to realize, right? Using C++, using these facilities in particular, is very easy, right? I'm storing a vector, that vector will be, you know, deleted and so on and so forth, right? And this kind of thing, right, is very easy to use, but it's not simple. The interplay between all of these different constructors and different things is not particularly easy. There's a lot going on, or it's not particularly simple, sorry, but it's very easy to use. And I think that's the key here. Easy to use does not mean simple, right? Easy to use is just, yes, I can use this very easily, but coupled with that, generally speaking, I would argue, is also the concept of misusing it easily. It's easily misused, right? There's a lot of emergent behavior when all of these systems come together on a language level here that we're not getting in the Odin example. Because in Odin, we ask for these things. It is obvious what's going to happen. When this goes out of scope, we're gonna delete that container, right? There's no question about it. It's exactly what's going to happen. And if this didn't exist, it wouldn't happen, period, right? Let's Odin run this, just so, yeah. And so the Odin version of this, right? Let's look also at our container copy, right? Because we had a copy constructor in the other case, right? Here, I have to ask for that. I can't just say E3 equals E2 and get a full copy, right? We're being more verbose here. Odin does not do this stuff for us automatically. We have to ask for this copy. Otherwise, what we would get is a shallow copy, basically. We'll take over some pointers, or we'll not take them over. We'll just copy over pointer values and so on. But this copy function here specifically makes a new dynamic array. It adds the values in the other side, right? And adds a fourth element as well. And then returns that new container. We have to be very specific, right? But there's also no question about what's going to happen, right? In C++, you can often accidentally run a copy constructor, for example, that copies massive amounts of data, for example. Or it copies a small amount of data thousands of times because we have a code path that simply constructs, deconstructs, and maybe, you know, does a lot of stuff. And if you don't believe me about this, I do think that there's something I want to show you here. So here is a post from 2014. It's quite old by now, but I think it illustrates a very interesting problem I think it illustrates the thing I'm talking about fairly nicely, right? So in the Chromium codebase back then, they did an analysis, this George Khalil, his team and so on. And they realized that when you typed one keystroke in the omnibox, which I'm not sure, but I think this is just the address field or whatever, right? The address box. When you type in this, right, one keystroke only, they allocated 25,000 times. And that might not sound like, you might not have a reference for that number, but that is an insane amount of allocations. We would never expect 25,000 allocations from even multiple actions, to be honest, at all. And this can be mitigated somewhat by having a global allocator that is smart about stuff, but it is not a good situation to be in, right? And the important thing here is this was not something they were aware of at all. And you can see here that the reasons for this that they found was strings being passed as char pointers and then converted back to strings. What happens in all of these cases? Well, something is turned into a char pointer, and that's really just a pointer access, basically. But then a constructor is run, right? Something has to run a constructor that takes a char string and then allocates memory for a string, and so on and so forth, right? Concatenating strings, created new strings, and so on and so forth, right? There's just a wide field of possible pitfalls here, right? And this, it also, you can see here, not reserving space in a vector when the size is known. That's also an interesting one, right? That means also the growth strategy for vectors was obviously bad as well. But I want to stress, this is not something that somehow C++ has solved either, right? This is an emergent behavior from all of the different smaller behaviors in C++. This kind of behavior can creep up on you from basically anywhere, right? You're using some value a certain way. That causes basically some constructor to run that maybe you didn't know about. You didn't think that that constructor would be the one. I want to show actually in the code that we looked at a case where you might not have noticed. This here, this constructor here, it's tempting to just say, oh, this is a function that takes this int blah, 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 and constructs this container, right? But what this actually is, in concept, is a conversion, implicit conversion operator, basically, when written like this. And what that actually means in practice, if we look at pushback here, no, actually, hang on, let's do this one. Yeah, element here, right? This is an implicit conversion operator. When we push back, we can see this is a vector of elements, right? What we actually want here, or what we actually have here, is this, right? This compiles, right? And so if I said, hey, let's remove this here, right? Or actually, let's make it explicit here. Now I've made this conversion explicit. And this means basically we have to cast something, we have to call the actual constructor in order to get this, right? And this can be a way to mitigate some of these pseudo disasters that can happen, right? But the important thing to realize here is when you have this constructor here, what you actually have is an implicit conversion from one thing to another. One here is basically this argument here, right? And that is then going to run the entire constructor. And if that constructor is very expensive, the code you have is going to look like, oh, pushback 1. That seems cheap, right? But this could, for all we know, in some code base, construct like 5 different vectors. And we might be constructing this value temporarily or something, right? And it looks very innocent. We're just pushing back 1, right? But this constructs a whole lot, right? It is not immediately obvious that there's basically a function that's being called here, a procedure of some sort, right? And so there's a potential pitfall here, right? That I think is important to kind of keep in mind. Because a lot of, when you talk to people who do really like RAII and so on and build a lot of things on it, what they will see is everything that you get, right, from it, from using it. They will see that, oh, I can actually automatically free stuff when stuff goes out of scope, which means if a value survives a certain scope, we're automatically not going to free that and so on. And it's so nice, right? But the cost here is that it promotes allocating and deallocating single things, right? Whereas when we're being explicit about things, we can say, no, I can free all of these at once, for example, right? And so on. Because we have that flexibility. We can say on a case-by-case basis, we can do that, right? In C++, that would require you to kind of not use the language as it's intended in some ways instead, right? And I think that's important to understand here, that the C++ way is simply, it's made to be used like this. You have to accept this complexity in some ways if you're going to use C++ like C++. A lot of people choose to use C++ like C, which I personally think is fine. But, you know, it's not C++, right? So yeah, let's recap a little bit, right? Let's go back to our simplest example. We have a very simple class here. It has only public members. Public is the only thing we have in Odin. Everything is public. We don't have methods. We can't put a procedure in here and expect to call it like a method. It's just not a thing unless we want function pointers inside of the object. Constructors, we don't really have them. We have procedures that return the thing, right? Destructors, don't really have them. We can run a procedure, right? You might see a pattern here, procedures, structs and procedures. That's the thing we have, right? We have unions, structs and procedures, enums. That's basically it, right? We also have cool, nice things like dynamic arrays and so on. We're not completely, you know, we're not Amish, but you know, we can have nice things, but the important things to take away from that whole section there is it's about having less, right? That we use less things to do the same stuff, right? And we have to do those things manually if we want to do them, generally speaking. So what about our slightly more complex example? We have this here, right? This constructor is doing things. We don't really have that. We have make a procedure, right? Have a procedure that does actually creates the thing, right? Take an allocator in that procedure if it's going to allocate stuff, probably, right? It's fairly straightforward, right? We return the struct. If we want to delete something, write the procedure. Write the struct name underscore delete probably, or whatever, or delete underscore struct name, right? It takes the thing and it clears it basically. And that's pretty much it, to be honest, right? There's not that much more to it, really. By the way, if you're wondering here why this dynamic array does not need an allocator to be passed for the delete, which you generally speaking would have, it's because if we look at the delete dynamic array, by the way, if you're ever confused about procedure groups, just check the specific one. This applies also to make. You might be used to seeing only make, but you should be aware all of these exist. So make, dynamic, array, len, cap, for example. This is make a dynamic array with a length and a capacity. Here you can see which arguments that takes. You don't need to be confused about this. So delete dynamic array here, because a dynamic array actually stores its own allocator, you don't need to pass it here, if you're wondering about that. If we want a copy constructor, which is this here, this is a copy constructor. It basically takes all of the memory and just tries to clone it, basically, right? But importantly, it does not share memory with the other thing, generally speaking. It tries to copy everything, so it has a separate copy, right? If we want that in Odin, we write the procedure, right? That procedure will do everything it needs to copy. And this is more manual. It is more explicit, right? So when I do have a copy here, I actually have this, right? I don't have E4 is E2, right? Because that would not copy stuff. It would not clone that element, basically. And so on. So yeah, that was just a kind of a brief intro to this. And again, I should stress, move constructors and so on, not a thing in Odin. Odin does not move your memory. If you're used to this from Rust or C++, there's no moving in Odin. If you want to do move memory yourself, you could absolutely do that, right? Copy to a new element, clear out the old element, or whatever it might be, right? There's no way of doing that in Odin that way. You would have to be explicit about this, right? But yeah, so that's it for kind of a very simple intro to translating some basic classes in C++ to Odin. This probably will be like a pseudo series in some ways. I'm going to do a little bit more on this. I want to do a video on FFI wrappers for C++ code and strategies that we can use to make that easier and so on. So we can use C++ libraries in Odin code when we need to, and so on. Spoiler alert, it's actually about using C inside of C++. But yeah, I will make a video on this as well. If you want to see something in this area, feel free to have, suggest in the comments. I am interested in this, trying to open up C++ a little bit for Odin programmers to maybe make that a little bit more accessible, so that people don't feel like, hey, this is C++, I don't want to get into it and so on. But yeah, so yeah, next episode will probably be about using C++ code in Odin projects and so on. But yeah, that's it for this episode. Have a nice day and ciao. I want to thank all my patrons for Hex 8. That's Jeff Ward, Matthew Cruz, Pavlin Nedelchev, Alex Ragali, and Radek Micek. For Hex 4, that's Ed Yu, Znanie, and Valentin Atanasov. For Hex 2, that's Dmitry Sereda, Mikhail Dobrev, and Nonlinear. Thank you for making the content on the channel possible.